IDEs build tools in JUnit. Now we are focusing on IDEs build tools. An integrated development environment, IDE, is a software application that provides comprehensive facilities to computer programmers for software development. An IDE normally consists of at least a source code editor, built automation tools, and a debugger. Some IDEs such as NetBeans and Eclipse contain the necessary compiler, interpreter, or both. Others such as Sharp Develop and Lazarus do not. Build automation is the process of automating the creation of a software build and associated process, including compiling computer source code into binary code, packaging binary code, and running automated tests. As an example, we can consider IntelliJ IDEA. The IDE support. IntelliJ IDEA supports running tests on the JUnit platform since version 2016.2. Note, however, that it is recommended to use IDEA 2017.3 or newer, since these newer versions of IDEA will download the following jars automatically based on the API version used in the project: JUnit Platform Launcher, JUnit Jupyter Engine, and JUnit Vintage Engine. IntelliJ IDEA releases prior to IDEA 2017.3 bundle specific versions of JUnit 5. Thus, if you want to use a newer version of JUnit Jupyter, execution of tests within the IDE might fail due to the version conflicts. In such cases, please follow the different instruction to use newer version of JUnit 5 than the one bundled with IntelliJ IDEA. In order to use different JUnit 5 version, for example 5.9.0, you may need to include the corresponding versions of the JUnit Platform Launcher, JUnit Jupyter Engine, and JUnit Vintage Engine jars in the class path. As an example too, we can consider additional Gradle dependencies in IntelliJ IDEA here. As an example 3, we can consider Eclipse. Eclipse IDE offers support for the JUnit platform since the Eclipse Oxygen 0.1a 4.7.1a release. You can see the execution of test here. NetBeans, as an example 4, we can consider NetBeans. NetBeans offers support for JUnit Jupyter and JUnit platform since Apache NetBeans 10.0 release. As an example 5, we can consider Visual Studio Code. Visual Studio Code supports JUnit Jupyter and the JUnit platform via the Java Test Runner extension, which is installed by default as a part of the Java extension pack. As an example 6, we can consider Gradle build support here. Starting with version 4.6, Gradle provides native support for executing test on the JUnit platform. To enable it, you need to specify use JUnit platform within a test task declaration in the build.gradle JUnit Platform Gradle plugin has been discontinued. The JUnit Platform Gradle plugin developed by the JUnit team was deprecated in JUnit Platform 1.2 and discontinued in 1.3. Please switch to Gradle standard test task. As an example 7, in Gradle, we can consider this one, configuring test engines. to configure support for the JUnit Jupyter base test, configure a test implementation dependency on the dependency aggregating JUnit Jupyter artifact, similar to the following here. In order to run any test at all, a test engine implementation must be on the class path. As an example 8, we can consider Maven. Starting with version 2.22.0, Maven Surefire and Maven Failsafe provide native support for executing tests on the JUnit platform. The pom.xml file in the JUnit 5 Jupyter Starter Maven project demonstrate how to use the Maven Surefire plugin and can serve as a starting point for configuring your Maven build. JUnit platform Maven Surefire provider has been discontinued. The JUnit platform Surefire provider, which was originally developed by the JUnit team, was deprecated in JUnit platform 1.3 and discontinued in 1.4. Please use Maven Surefire native support instead. As an example 9, we can consider Maven configuring test engines. In order to have Maven Surefire and Maven Failsafe run any test at all, at least one test engine implementation must be added to the test class path. To configure support for JUnit Jupyter based tests, test scope dependencies on the JUnit Jupyter API and the JUnit Jupyter test engine implementation, similar to following. As an example 10, we can consider Ant. Starting with version 1.10.3, Ant has unit launcher task that provides native support for launching test on the JUnit platform. The JUnit launcher task is solely responsible for launching JUnit platform and passing it to the selected collection of tests. The JUnit platform then delegates to registered test engines to discover and execute tests. As an example 11 in Ant, we can consider this segment, the basic usage. Here this example demonstrates how to configure JUnit launcher task to select single test class, that is org.myapp.test.myfirstJUnit-test. As an example 12, we can consider Spring Boot. Spring Boot provides automatic support for managing the version of JUnit used in your project. In addition, the Spring Boot starter test artifact automatically includes testing libraries such as JUnit Jupyter, AspectJ, Mockito, etc. As an example 13, we can consider Spring Boot here. Configuration with Gradle. You can override the JUnit Jupyter version by including this in your build.gradle file. As an exception example, we can consider this. In Eclipse, the test would be marked as passed even if the test method throws an exception, which is a subclass of the specified exception in the at test expected clause. As an exception example 2, we can consider this occurred in environment with Gradle and JUnit. error gradle org.gradle messaging org.gradle.messaging.remote.intel internal.hub.message hub back to object connection, unexpected exception thrown, etc. and caused by java.land.nullPoint exception at java.land.throwable that.set stack trace throwable at org.gradle.messaging.remote.internal message exception placeholder.read. As an error example, we can consider this occurred in the environment with IntelliJ IDEA, Maven, and JUnit 5 here. And you can see process finished with exit code -1 here. As an error example too, we can consider this occurred in environment with Gradle. Here compile Java. Users workload project gradling source test calculate test.java error package org.junit does not exist, etc. And here 5 errors and compile failed, failure, built failed with an exception, etc.